Hello to us all. So we are going to be looking at more graphing today. We're going to be looking at some features of graphs and some things to make sure that we all are okay with. We need to talk about what it means when a problem says to sketch a graph versus draw a graph, because those are two definitely different things. Sketching a graph, you're showing the overall shape and indicating important features. When you draw a graph, that's when you need a very, very accurate scale. You need to be using a straight edge. You've got to do a much more precise job when it says to draw a graph versus sketch a graph. So, some of the main features you should include: the Y-intercept. That is where x equals 0. We can always find that point by plugging in x equals 0. The x-intercepts, the zeros, there where y equals 0, maximums and minimum points. We're also talking asymptotes. A vertical asymptote occurs where a function ceases to be defined. They are vertical lines of the form x equals a. You always need to label your asymptotes with an equation, ladies and gentlemen, not just a number. And a horizontal asymptote indicates the long-term behavior of the function. So as we go really far to the right or really far to the left, positive and negative x directions, what is the graph doing? What y value is it getting closer to? These are horizontal lines that have the equation of the form y equals a number. So let's get into this. So again, defining what an asymptote is, it's a straight line which the graph approaches as either x or y gets very, very, very large. So this is a funny looking function. X times e to the negative x plus 2. I'm seeing the plus 2. I'm thinking maybe that's something, but not real sure. What we could do is we could plug in x equals 0. Think about what that's finding us. That's finding us the y-intercept. So we'll have y equals 0 times e to the 0 plus 2, so y equals 2. When we sketch this graph, we have a y-intercept of 2. And really, that's all I really know right now without some much more advanced mathematical techniques. So what I can do is I'm going to go to my graphing calculator. X times e to the, I forget what it is already, negative x, and then plus 2. So there's our graph. Y-intercept of 2, just like I found before. We have one x-intercept, it looks like. I can go ahead and find that. We go analyze graph, intersection, not intersection, I lie. How about zeros? There aren't two graphs to intersect. So lower bound, upper bound, there's my x-intercept. Now it looks like it's leveling off here. So I'm going to go to my table and I'm going to see if I can't identify a horizontal asymptote. So there's my y-intercept. It goes up above 2, but then notice it gets closer and closer and closer to 2. So I'm thinking that the y, or the horizontal asymptote, the horizontal line y equals 2, needs to be on my graph. I'm going to lose my table. And let's go ahead and find the maximum also. Something that we should include on our pictures. So there's the maximum of this graph. So now I just need to reproduce this on my sketch. So negative 0.85. 853, 1 comma 2.37. And then we have an asymptote going right there at y equals 2. And our curve comes from down here. It's a horrible curve. Let's try this one more time. And it scoots out along that asymptote. A thing to take away from this is that graphs can cross asymptotes. When we say that it never touches the asymptote, we're talking about what's happening as x gets really, 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 really big or really, 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 really small. So there's our sketch. We've got our important features labeled. We're ready to go on to the next graph. Sketch the graph of this. Whoa. So natural log, absolute value x minus 2. Remember, with logarithms, we cannot take the log of 0 or negative numbers. But since we have the absolute value function here, that's going to take whatever's inside and turn it positive. But if x was 2, then we'd be taking the natural log of 0, which is undefined. So what are we going to see at x equals 2? We're probably going to see a vertical asymptote. So this is what I'm thinking. The graph cannot be defined for that value. So let's go to our calculator. And I'm going to throw a new graph page up here. Natural log. And then absolute value. Well, the place we can find that is this button right next to the 9. It has a whole variety of different features, different functions. So I'm going to select that absolute value, and now I type x minus 2. And there it is, and it looks like a V. Whoa, what's that about? Well, what there actually is right here at 2 is a vertical asymptote. And the calculator does have limitations. It can't go infinitely close to that asymptote down here. It looks like it stops, but it doesn't really. It just approaches the asymptote from both sides. So we need to find our points. Let's throw our x-intercepts up here. So we have x-intercepts at 1 and 3. It appears there is no maximum. It goes up forever. There is no minimum. It goes down forever. We do have a y-intercept here. I'm going to find that on my table. So when x is 0, we have 0.69. And I'm ready to sketch my graph. So we have an x-intercept here. We have an x-intercept there. That's 1. So when we sketch this in, looks like this. We're approaching the asymptote from both sides, but neither one ever crosses it. There's my sketch, good to go. On to the next. So here we have a rational function. It's a fraction. It's got x's on the top, x's on the bottom. Let's think before we start graphing. When does a fraction equal 0? That is, if I'm looking for the x-intercepts, that's when y is 0. So when does y equal 0? Y is 0 when the numerator is equal to 0. So x cubed minus 16x equals 0. That's a fact about fractions. When the numerator is 0, it's equal to 0. And this I can factor. I skipped a step here. I pulled out an x. Then I have a difference of squares. So this is equal to 0. X could be 0. X is 4, negative 4, or x is 4. So I'm able to reason that out without any help from the calculator. Likewise, I can find the y-intercept. I can find that by plugging in x equals 0. So the y-intercept is going to be y equals 0 minus 0 over 0 plus 1. That's 0. So the y-intercept is 0 comma 0. All right. Now let's think about vertical asymptote. Where is a fraction not defined? Well, a fraction isn't defined when the denominator is equal to 0. So denominator equals 0. Can x squared plus 1 equal 0? That's what we're wondering. If it can, that value of x is going to be an asymptote. But x squared plus 1 can't, so there is no vertical asymptote. And we can verify all this information, hopefully, going to our calculator. So here comes our last graph of the day. We have a fraction. X cubed minus 16x over x squared plus 1. Holy cow, look at this one. This one we have to change our viewing window. So I'm going to come up here, double click on the Y maximum. Let's go to 10, see what happens. Press tab, go on X maximum, we're okay. Y minimum, let's go negative 10. And there we go. We can see all the important bits and pieces now. We see the x-intercepts that we were expecting. We see the y-intercept that we were expecting. We see that there isn't a vertical asymptote. What we now need to find is the maximum or minimum. So there's our minimum that we can label on our graph. There's the maximum that we can label on our graph. And then we could sketch this on our page. So, one thing that you need to take away from this video is you should try to look critically at any function that you're given and that you need to graph and see what you can deduce about it from the equation itself, from the function. Can you tell what the x-intercepts are going to be? Can you tell if there's going to be an asymptote? Those things are important. They're things that you should be able to figure out without your calculator a lot of times. It not only can save you some time, but it can also identify when you type something incorrectly into the calculator. The calculator is limited. It is not an all-knowing piece of technology. It graphs exactly what you typed in, but sometimes it doesn't do a real good job, like that one that looked like a V. So just some stuff to think about, some things to remember, and that is where I shall leave you for today.